How do I recognize an exercise belongs to Boyle, Charles, or Gay-Lussac? Just remember this. For Boyle's law, we have one condition. The condition is that the temperature is constant. Okay? So, for Boyle's law, remember this. Temperature is constant, which also means remains the same, remains unchanged, the temperature didn't vary. Okay, so there are many ways to say it, but just in the end, it's the same. The temperature doesn't change. Okay?
Please, can you repeat it? I didn't hear you very well.
I was saying that for Boyle's law, the condition to know if we need to apply one equation or another is that, for example, in Boyle's law, the condition is that the temperature is constant, which means that remains unchanged. The temperature does not change. Okay? So, what can we do for these exercises? Just remember here, for Boyle's law, we have constant temperature, and as you can see, in all the formulas, we don't have temperature. Okay? We don't have temperature involved in these problems. But we do know is that it remains constant. So another tip that you have to take in account is the units. Okay? For example, I am giving you a pressure. Okay? I am giving you pressure. Guys, how well do you listen to me?
It's okay, miss. You hear clearly.
It sometimes it cuts and then it goes back at normal again. It's
Okay,
just sometimes.
wait. Uh, what about now? It's the same.
It's
What I was saying about the pressure is that all you need to do is checking that you have the same units. For example, here, the two pressures that I'm giving to you are 12.7 kilopascals and 8.4 kilopascals. So we have the same units, kilopascal in both. So when you have this, means that there's no need to do a conversion for pressure, okay? Because the units can be cancelled. But if the units are different, you have to do a conversion in a way that you can have the two pressures. Now, let's take a look. The problem here is given us, it says a 40 liters tank of ammonia has a pressure of 12.7 kilopascals. Calculate the volume of the ammonia if its pressure is changed to 8.4 kilopascals while its temperature remains constant. So first of all, we have to write the data provided, okay? So here, the problem is giving us an initial volume, which is 40 liters, okay? Then we have a pressure, initial pressure of 12.7 kilopascals, okay? It says calculate the volume of the ammonia. So I need to find the volume too, not my final volume, because my pressure changed to 8.4 kilopascals. So this is going to be my final pressure, 8.4 kilopascals. And because I need to find V2, I'm going to look for the equations, the one that is useful to find the final volume, which is the last one, okay? So we write it down, and then we replace by the givens. We say volume 2 is going to be equal to the pressure 1 times volume 1 divided by the pressure 2. Okay? So volume 2 is going to be equal, volume 2 is going to be equal to, and now we replace by the givens, pressure 1, that is 12.7 kilopascals, times the volume 1, that is 40 liters, all this divided by 8.4 kilopascals. This allows us to cancel the units kilopascals with kilopascals, and the remaining unit is going to be just liters. So your final volume, now you perform this in your calculator. How much did you get?
86.48.
60.48. So what happened with the volume? The volume expands. So it makes sense. Okay? And with this, we finish Boyle's law. Now, what happens after? We have Charles' law. Okay? What do we need to know about Charles' law? There is a condition. It has to be
in Kelvin.
the temperature must be in Kelvin. But here, in this kind of problems, how do we recognize if we have Kelvin? I mean, if we have Charles' law. In Charles' law, the condition is that pressure is constant. Okay? The pressure here is constant, which means no change in pressure. Okay? So, in the formula, as you can see, there's no pressure involved in any of the formulas. No pressure involved. So, when this happens, I don't know what I did. Wait. So, when this happens, ay, no sé qué hice. Oh my God, what I did. Okay. I think I deleted the page. No. Okay. Sorry guys, honestly. I don't know what I did. Well, the good news is that it's back. Now, take a look here. The other condition that we need to be aware of is what I think Raquel said it, is the temperature. The temperature for this problem must be in Kelvin, so we must perform conversions whenever needed. Now, what givens can we write from this word problem? It says, if 15 liters of neon at 25 Celsius degrees is allowed to expand to 45 liters, what must the new temperature be to maintain constant pressure? So, the last part of the problem, the word problem, tells you that actually this is a Charles' law because we have constant pressure. Now, the givens in the word problem are 50 liters at 25 Celsius, and then it expands to 45 liters, and they're asking me to find the new temperature. Okay, so we have the initial volume of 15 liters, we have the initial temperature, that is 25 Celsius, we have the final volume, that is 45 liters, and we need to find the final temperature. Okay, so what we need to do in the first place is perform any conversion that you can find. Okay, so the temperature one, that is 25 degrees Celsius, we need to convert it to kelvins. So we say 25 plus 273 is equal to 298 Kelvin. So this is going to be your initial temperature, but in kelvins. Now from this, we apply the formula to calculate the new temperature or the final temperature, which is this one, the last one, okay? So we write down the formula and we say temperature 2 is equal to temperature 1 times final volume divided by initial volume. And then we substitute by the givens that we have the initial temperature in Kelvin, because that's why we did that conversion. So we say 298 Kelvin times the second volume, that is 45 liters, divided by the initial volume, that is 15 liters. This allows us to cancel the liters. And in the end, the final temperature is equal to what? How much did you get? 894 Kelvin. And with this, you finish the exercise. But there is a high chance that I tell you express the new temperature in Celsius. So if I tell you to express the temperature in Celsius, then from the temperature that you got in the first place, you will have to perform the conversion to Celsius. So this is going to be temperature 2 minus 273 to give the temperature in Celsius. So this is going to be equal to 894 minus 273. How much is this? $621.
21.
So this is just in case that I ask you to express the answer in Celsius. But you might be thinking, Miss, but isn't it better that we work with Celsius in the first place? I'll show you what happens if you use Celsius without conversion, okay? So this is the process that you never do, okay? So do not do this. So in the case that you think that you can use directly the Celsius, this is what you could get, okay? Temperature 2 equals 25 Celsius times 45 liters divided by 15 liters. So this is going to give you 75 Celsius. Do you see the difference? That's why it is mandatory to do conversion to Kelvin. We work all the procedure in Kelvin. And if I ask you in Celsius, the conversion is going to be the last step you do. But all the procedure must include kelvins, okay? Kelvins, do not forget. So don't do it incorrectly. Don't do like I did in the red part. This is the way it should be, okay? Like that. But that's just in case I ask you guys. No, it should be in Celsius. Okay, if I tell you that, you have to do this procedure. So far, do you have a doubt, a specific doubt?
Miss
Miss
in the
in the
kung
the
gaw.
Gao. Gao.
In the second one,
No,
No,
the
the
EK is
is
going
going
to
to
be the
be
quiz.
that if it's coming in the quiz, sorry, I can't hear you very well. If that's your question, yes. All the laws. But I couldn't hear you very well. So if that was not your question, you can text me. How do we recognize Gay-Lussac's law? For this law, we're gonna have constant volume, okay? So this keyword over there, the one that says constant volume, is the key to know if we have to apply Gay-Lussac's law when the volume is constant. And therefore, in all the isolations, volume is not going to be involved, okay? So for this problem, we have, it says, the gases in a hairspray can are at a temperature of 27 Celsius. That is the initial condition for the object, okay? And a pressure of 30 psi, pound over square inches. If the gases in the can reach a pressure of 90 psi, the can will explode. To what temperature must the gases be raised in order for the can to explode? Assume constant volume. So they are giving us initial temperature of 27, initial pressure of 30, and final pressure of 90 psi, because I want the can to explode. Okay, so I need to reach the pressure of 90 psi. So I write down the givens. And I have an initial temperature of 27 degrees Celsius. I convert it to kelvins by adding 273. Sorry, okay. So this is going to give me 300 Kelvin, right? 27 plus 273 should be 300 Kelvin. And we already performed that conversion. Even though the conversion is very simple to make, you have to show the procedure in the quiz. Then we have initial pressure of 30 psi and a final pressure of 90 psi, and I wonder what the temperature 2 is going to look like. So now I'm gonna focus on the formula for temperature 2, and I'll just write it down and replace by the givens. So temperature 2 is gonna be equal to temperature 1 times pressure 2 divided by pressure 1. Substitute by the givens. We have 300 Kelvin initially, 90 psi that you want to reach, and initially you have 30 psi. You cancel psi with psi, and the final temperature that you must reach the can is how much? How much? Sorry, I couldn't hear you.
900.
900 Kelvin. And with that is fine. Okay, with this is fine. Now if I ask you to calculate the temperature in Kelvin, I mean in Celsius, so you just have to subtract 900 minus 273, and this is going to give you 627 Celsius. So you see, right? Okay, I work the entire exercise in Kelvin, and if I have to express answers in Celsius, after and just after, I'm gonna do the conversion. Okay, but just like this is fine. Now, the other formula that we have involved in these laws is the combined gas law. Okay, so let's see. In combined gas law, the equation is a little larger, okay, but in the end, it's implicit, okay? All you have to do is there implicit. So we need to highlight the givens. So it says a gas is heated from 263 Kelvin to 298 Kelvin, okay? And the volume is increased from 24 liters to 35 liters by moving a large piston within a cylinder. If the original pressure was 1 atm, 1 atmosphere, what would the final pressure be? So I'm asking you to find the final pressure, okay? So in the list of the givens, we just need to organize the data. The initial temperature is the one that is coming from, so it is 263 Kelvin. The final temperature is the one that you want to reach, which is 298 Kelvin. So in here, you don't need to do conversion because the temperatures are already in Kelvin. The initial volume is 24 liters, and the final volume is 35 liters. If the original pressure was 1 atm, so pressure 1 is 1 atm, what is the final pressure? That is what I want to look for. So, in all the isolations, all I have to do is finding the pressure 2. I will write down the formula. So it says pressure 2 is going to be equal to pressure 1 times volume 1 times temperature 2 divided by temperature 1 times volume 2. And we just substitute by the givens that we have. Pressure 1, that is 1 atm, volume 1, that is 24 liters, temperature 2, that is 298 Kelvin. All this divided by the temperature 1, that is 263 Kelvin, and the volume 2, that is 35 liters. This allows us to cancel liters with I forgot. This will allow us to cancel liters with liters, kelvins with kelvins, and the remaining unit must be atmospheres. So my second pressure, my final pressure for this gas is going to be how much? How much? Guys, remember that everything here is gonna be multiplied. So in your calculator should be 1 times 24 times 298, and everything below is going to be divided. So it's going to be divided by 263 divided by 35. How much is that?
0.77.
0.77. 78 rounded, okay? So be careful on that part. That's why I'm going to leave there the calculator procedure. And voila.
What is the cost of my lab?
Did you get the same answer? Check. Because then in the quiz, I cannot help you. So just remember, everything at the top multiplies, everything below divides.
What is the cost of my gas?
I can't hear you. Can you send me the question as a message? Okay, let's see. In combined gas law, we don't have constant, okay? That's why we have here all the three data involved. We have temperature, we have volume, and we have pressure, okay? So here we don't have any condition that is gonna be constant, okay? So all of them will have vary, okay? The pressure is different, okay? Initially it was 1, then it was 0.77. The volume changes from 24 to 35, and the temperature changes from 263 to 298. So in this combined gas law, we don't have constant, okay? So I'm just gonna write it down. Thank you for reminding me. No constant data. Okay, no constant data. And now in the last part, that is partial pressure for Dalton. I'm going to read this example, very simple. Okay, just for you to remind it. Oxygen gas from the decomposition of potassium chloride was collected by water displacement. The barometric pressure and the temperature during the experiment were 740 torr and 25 Celsius respectively. What was the partial pressure of the oxygen collected? So, in Dalton, we have that total pressure is equal to the pressure of the gases. So it depends on the amount of gases that you are going to have. Here in this exercise, we have oxygen gas and water, but water, okay, in this case, we are talking about water vapor because that is the gaseous state of water. So this actually is water vapor. Okay? Now, for this, because we only have two gases, the equation is going to look like that. So the total pressure, that is 740 torr, is going to be equal to the pressure of the oxygen gas plus the pressure of water. For the pressure of water, I need to use the table, okay? So I'm going to focus on the temperature of 25 Celsius and the pressure that it should be in the same units. Remember, torr and millimeters of mercury are the same. So the pressure for water vapor, in that case, is going to be 23.8. So now I isolate for the pressure of the oxygen gas, and it's going to be equals to the total pressure Okay, so as I was saying, it's going to be the pressure of the oxygen is going to be the total pressure. This is already isolated. Okay, the total pressure minus the pressure of water vapor at 25 degrees Celsius. So now we just substitute by the givens. The pressure of oxygen gas is going to be the total pressure, that is 740 torr, minus the pressure of water vapor, that is 23.8 millimeters of mercury, which is also the same as torr. Okay, just remember this. Millimeters of mercury is equal to torr. Okay, now we perform the subtraction. Okay, we perform the subtraction. So this gives us 740 minus 23.8 give us 716. So the pressure of oxygen gas is equal to 716.2 torr, and this is the final answer. And with this, we already finished the review before the quiz. Thanks, guys.